Today, we will look at how you can use Descope to build fine-grained authorization models for your applications. In this example, I will be developing a smart home application that will let you control a variety of smart locks, security cameras, garage doors, and other IoT devices you may find in your home. Authorization like this cannot be done with roles-based or attributes-based access control, as we need to be able to define access for each individual device based on dynamic relationships, rather than some static list. Let's begin. First, we will need to build our model schema. To start, we will define the different types, sometimes called entities, we will have in this model. Types will be both the resources being accessed, as well as the subjects that are accessing them. In our example, users will be accessing the IoT devices, so we will have both a user type and the device type. Now we could have separate types for all the different IoT devices you might find. For example, have one for the locks, another one for the security cameras, but there will be a lot of overlap in the relationships and permissions for all of these different devices. So instead, I will define a single device type to keep the namespace nice and clean. Lastly, I want to have a concept of a group of devices, so I can group all devices belonging to a room, a unit, or the whole home and grant permissions for the whole group rather than doing it individually. So my final type will be device group. Now, let's start to define the different relationships and permissions that can exist for each of the types we defined. For each device and device group, I want to be able to define 3 different relationships with varying levels of access control. Let's first define an owner. This will be the person that has super admin privileges for the devices and groups. The syntax is the name of the relationship, colon, and then what type can form that relationship, in this case a user. So the schema now says that I can create the relationship owner between a user and a device group. Similarly, I want to create the relationship operator. This will be someone that has control over everything outside of privileges I only want the owner to have, like changing the lock code. And finally, guest, for someone I want to grant limited control to. These same relationships will exist for the devices, so I will copy them over. But in addition, there will be a relationship between the devices and the device group. This relationship needs to exist for the permissions to be inherited from the group. So we will define a parent relationship between device and device group. Now that we have the relationships defined, let's define some permissions. For the device group, I will add the permission can add device and will only allow the owner to add devices to a device group. I will also want permissions for who can add an operator to this group, which I will once again only let the owner do, and similarly, who can add a guest, which I will let both owners and operators do. For the devices themselves, I will want a permission for who can change the codes for the locks, which I only want the owner to have. But if the device belongs to a group, I also want the owner of that group to be able to change the code. This is why this type of authorization use case requires relationship-based access control, as access control decisions can be inherited based on relationships that exist. So in my schema, I will allow the owners of the parent to also have this permission. I will also have permissions for who can view the security cameras, which I will allow operators to do as well as owners, and lastly, who can open locks, and everyone including guests can have that permission. Notice that I can reference other permissions to make the schema cleaner and easier to read. Now that my model is done, let's begin to add some relationships. To start, I will have the user Bob create a device group called Home and will assign him as the owner to this group. So let's create that relationship. Note that you should be using a unique identifier like the Descope user ID, but for simplicity, I will use friendly names in this example. Now, since Bob is the owner, he will be able to add devices to his home group. So let's add the device front lock, back lock, and camera to the device group by creating that parent relationship. And lastly, let's assume that Bob is renting his basement to a tenant, Alice, and he would like Alice to have operator control of this home group. So let's create the relationship operator between user Alice and the device group Home. Now that we have some relationships defined, let's test the behavior by writing some assertions. An assertion is a test case where you define the expected behavior so you can make sure your model is functioning as expected. Since Bob is the owner of the device group Home, I know he should be able to add an operator to this group, so let's make sure that returns a true. Similarly, I know Alice would not be able to, so let's ensure that returns false. Bob will also be able to change the code on any of the locks, so let's test to see if Bob can change the code of the front lock. This is an important test case because note that I never explicitly gave Bob this permission, but since he's the owner of the device group Home, and Home is a parent of the front lock, Bob inherits that permission. Conversely, let's check to make sure Alice cannot change the code to the back lock. But Alice should be able to view the security camera so she can check in on her cat while she's at work. So let's make sure that returns true. We can run a check and make sure all of our test cases pass, which they do. Let's add one more piece to the model and define a user group. Let's say maintenance needs access to the HVAC unit while Bob and Alice are away, so they would like to grant them guest access. If maintenance is sending multiple people, for example Charlie and David, rather than give permission individually, it would be easier to define a user group. So let's add a user group to the model and define a relationship member. Now, everywhere in my model where a relationship could exist with a user, I will also allow creating that relationship with a user group and give all members of that group that relationship. For that, the syntax is user group #member. Let's add a few more relationships. We'll create a user group called maintenance and define member relationships with Charlie and David. Lastly, I will create the relationship guest between the maintenance user group, and in this case, I only want that relationship to exist on the back lock, so I will specify the device instead of the device group. Let's do some final assertion checks and test our model. I will first check to see that Alice can add guests to the device backlock, which I am expecting to be true since she's an operator of the group Home. Then, I will check to see if Charlie can open the backlock, which I am expecting to be true as well. I will also test to make sure Charlie cannot change the code of the backlock. Finally, I will check to see that David cannot open the front lock since maintenance only has access to the back lock. After running those tests, I see the model is working as I intended. Hopefully this walkthrough showed you how you can use Descope to build fine-grained authorization models in your applications so your users can safely and securely access the resources they are permitted to access. Thank you for your time.